Bismillahirrahmanirrahim. Sallallahu ta'ala ala Muhammad sallallahu alayhi wa alihi wa sallam. Boys, we will discuss chapter 11 of class 10th and exercise 11.1 of question number 1. In this question, the questionnaire says that in a circle two equal diameter AB and CD intersect each other, then we have to prove that the chord AD and BC are equal, right? Before starting this theorem, boys, we have to use some things, few points that are known as circumangle and central angle. So I want that I should define a central angle. Central angle subtended by two radii of the vertex. Okay, these are the two radii with common vertex, that is center, and so this angle is known as central angle. Right? This angle known as central angle. Central angle is subtended by two radii with the vertices at the center of the circle. Right? Now, what is circumangle? This angle is known as central angle. Right? So, if we define what is circumangle, right? The circumangle is subtended between any two chords. Between any two chords. Let's suppose that the diameter is also one chord and there is another one chord, right? So this is angle, right? A, B, and C. AC is a chord and AB also chord. So the angle subtended between any two chords of a circle having common point on its circumference. So this is a common point on the circumference of a circle, right? So this angle is known as some circumangle. Circumangle. Because I have told you these two things before starting our lecture, before starting the theorem, or before starting the actual question, because we use these two things in this theorem, central angle and the circumangle. So you must understand it that what is a circumangle. Now come toward the required question. So what is our required question? Let's see. Here the question says that we have given the two diameters, right? We have given two diameters in a circle. Let's see. This is our circle. If I hope so, it's going to be a circle, right? So there are two diameters. Let's we say that this one is a diameter, and this one is also known as a diameter, right? I notate these diameters as A, B, and C, D. A, B, C, and D, right? So what we have given here, we have given only two diameters and they are equal diameters, right? Same point, equal diameters A, B, and C, D. So I have to write given, right? In circle, this is your center O, right? In a circle with center O, two chords A, B, and C, D intersect each other, right? A, B, and C, D. In circle with center O, right? In a circle with center O, we have two chords such that A, B congruent to C, D, right? These two things that we have given. Fine. What we have to prove? We have to prove that AD. So this is our requirement. AD. I just notated with the dotted lines. We will include this in a construction step. We have to show that AD congruent to BC. This is our requirement. What is our construction? Right, join the points, join A to C and D to B, right? Join A to C and B to D. It, right, one thing that we join these two things. Another one that there is angle 1 and this one is angle 2. These are two central angles. Right? This AD is a chord and CD is a chord. So this is known as central angle. AB is a chord and BC is a chord. So this angle 2 is known as a central angle. Right? Join A to C and B to D. We get two central angles. Sorry, not central, circumangles. Fine. We get two circumangles, angle 1 and angle 2. Right? Now we move toward the statement that reason wise. Statements and reasons. Right? So what are our statement reasons? In the triangles, look at here, in the triangles B, C, D, this one triangle B, C, D, right? In the triangle B, C, D, or you can say C, B, D, and the another one triangle is B, C, A, B, C, A, right? B, C, A. This one triangle and this one, right? So BCA, the triangle BCA and triangle BC1. What we have here, let's see. In triangles CBD and CBA, right? CBA and CB and D, this one triangle. In these triangles, what we have common, right? BC is a common in both. BC is a common in both. Okay, boys. No, just I made some changing in the diagram. Angle 1 and 2 are representing here. A, C and BC. This is angle 1 showing the angle 1. A, B and DB. This is showing the angle 2. Now we are going to prove that the side BC and BC is common in both these two triangles. The side BC and the side BC is a common. So this one is the common side, right? This one is a common side. We have made some changes in the diagram and also in the theorems. I have written already now. In the statement reasons, we have to show that in the triangle CBD, C, B and D, this one a triangle C, B and D, this portion, right? CB and BD. So CBD, this one is a triangle, right? And CBA, CBA means CBA. C, B and A. This one is another one triangle. Right? We are going to show the correspondence between these two triangles, CBD and CBA. For this CB, definitely I use the word CB two times, so CB is a common thing. The next one, AB and CD. What about the AB? AB is a diameter, CD is also diameter, which is already given, and in the given AB congruent to CD, so we have written there AB congruent to CD. Now what about the angle 1 and angle 2? The circumangles of the same segment. Angle 1 and 2, this is angle A, C and D, right? Look at here. A, C and D. So CD and AC make angle 1, right? This is known as a circumangle. The next one is AB and BD. AB and BD, right? This is angle 2. These two angles are congruent because they are circumangles in the same segment. Why we say the same segment? Because AB and CD both are congruent. So that's why we will say that whenever these two diameters are congruent, definitely 1 and 2 will be congruent because they are circumangles. So they are circumangle of the same segment. Now, angle CBD. What about the angle CBD? C, B and D. This is complete angle CBD, right? Look at here. This one. CBD. I am talking about this angle CBD and the angle BCA. BCA. This one. Right? I already highlighted. These two angles are congruent. Why these are two angles are congruent? Because opposite angles in the same segment, both angles, because they are present in the same segment. So look, you can see this one and this one. If this is the same portion, then angle this and angle 1, this one, both are same angles in the same segments. Isn't that same opposite angles in the same segment? Now from when we subtract this equation third from the fourth, we get Mayer angle CBD minus Mayer angle 2, that is equal to Mayer angle BCA minus Mayer angle 1. What I am saying, that Mayer angle CBA minus Mayer angles, you can say that ACD, right, are the Mayer angle 1, and Mayer angle CBD, when I subtract the angle 2 from it, then what we get? I get that Mayer angle C, B and A, right? What is left? Mayer angle C, B, A. This one angle, right? This angle will be left, and Mayer angle BCD. Mayer angle BCD, this will be left, right? This portion and this portion. These two angles will be left whenever we subtract 1 and 2 from it, and I notated with the equation 5. Now, according to these points, if I included again CBD congruent to CBA, both angles become congruent, and the reason that SAS postulate. Why we use this SAS postulate? Look at here, boys. We say that BC is a common, right? BC is a common one point. CD and AB from, you can say, 1, 2 and the fifth points, right? From 1, 3, I write it from first, second and fifth. From these 3 points, I get that these two triangles are congruent, and reason is that SAS postulate. So whenever we prove that the both triangles are congruent, CBD and CBA, CBD this triangle and CBA, these two triangles congruent, then their corresponding side definitely become congruent. So AC congruent to BD, I write that AC congruent to BD. So similarly, we can prove it that AD will be congruent to the BC. AD will be congruent to the BC. Hence, this is our requirement, that AD congruent to BC. AD congruent to BC, and we can also prove it. Behind this proof, we have to take all these steps. So just I write the word similarly. AD congruent will A congruent to BC. AD congruent to BC, which is our requirement. Okay, boys. Thanks. Wish you best of luck. If you want to ask any question, you can ask.